All right, let's take a look at something called consecutive integers and perfect squares. Consecutive integers and perfect squares, you find it all the time on a standardized test. It says you take a number. Let's take 40. What are the consecutive, oh, there should be a square root sign around it. My software also does not allow me to do square root signs, so here we go. And that's how I do it. Oh my God, sorry. So square root of 40. Where does that fall on a number line? Between which consecutive integers? You remember, integers are whole numbers and their inverses. So not decimals. So I'm looking for whole numbers and their opposites, their negatives. So square root of 40 can be found between the integers 6 and 7. How do I know that? Well, I know it because 40 falls between which two perfect squares? 36 and 49 are perfect because I've memorized those. And I know the square root of 36 is 6, the square root of 49 is 7, so therefore the square root of 40 falls between 6 and 7. If I'm using a calculator, I am just putting 40 square root key in, and I get 6 point ... decimals. That means my integer is the whole number, 6. And the next one in consecutive order, 7. Inverse or negative square root of 90. Well, let's just look at 90. The square root of 90 is going to fall, and we know it's going to be an inverse, it's going to be a negative, but the number 90 falls between 81 and 100. Square root of 81 is 9, square root of 100 is 10, and I want negative, so I make these negative. Negative 9 and negative 10. Now I'm on the negative side of my number line, so my numbers are going to the left, not to the right, but they're still consecutive. When a radical is not perfect, it falls between two perfect squares. And those two perfect squares translate into consecutive integers. Try it on your own. I don't have the device that allows me to cover this. Square root of 156 in your calculator is 12 point something. So I put in 12 plus 1, 13, consecutive. Square them, my perfect squares, 144. Square 13, my perfect square, 169. So if I was doing a number line, I would have the square root of 156 falls between 12 and 13 on a number line. Rational versus irrational numbers. Rational numbers, they end or they repeat, but you know what comes next. If you know what the next value is, then you know that it is rational. I know that this is 2, 3 repeating, which means my next digit is a 2 and a 3, a 2 and a 3. If I know what comes next, or it ends, that's rational. It makes sense. But if I have no idea what comes next, it's irrational. Irrational means that the integer never ends and it never repeats. You cannot predict what value will come next. Usually and often they are created by square roots or from square roots. The value goes on for infinity. Square root of 72. You can put it in your calculator and you just get a number that goes on and on and on. It is irrational. In order to solve it or to make it usable, you need to round it. So either round to the nearest tenth, round to the nearest hundredth, but you have to use your rounding skills. Underline the 10th place value, look to the right to determine if you round up or you stay the same. In this case, 8 says round up. My answer is 8.5. Rational versus irrational numbers. We all started kindergarten and first grade with whole numbers, positive, 0, 1, 2, 3, 4. We learned how to count on our fingers. We learned how to count everything. 0 is a whole number. We moved on to integers. This is where we were introduced to negatives. We started a number line and we had 0 in the middle and positive numbers to the right, negative numbers to the left. Rational. Rational numbers include decimals, fractions, repeating decimals. They include integers. They include whole numbers. These are all rational. Integers include whole numbers. Rational include integers and whole. Real includes all numbers, whether they're rational or irrational. Irrational, very short list here. Repeats, values that you have no idea what the next number is. They do not repeat. Never repeats. Note, another one type of number that is not real is called undefined. We have here the square root of -11, which up until this moment, you know doesn't exist. You can't do it, undefined. You're going to find out when you get to Algebra 2 and Trig that there's something called small I, and this I is called imaginary numbers, and it does exist. But that's for a later day and a later time. But there is a number called imaginary I, and it entails the square root of negative numbers. Spoiler alert, it's coming. Here are some rules. When you're looking at rational and irrational and you get questions, if you add 2 rational or multiply 2 rational, what do you get? If you add or multiply one of each, what do you get? Irrational. If you add or multiply 2 irrationals, you can either get a rational answer or an irrational answer. But I have an exception to this rule. Here, if I am adding 2 rationals or irrationals, if you add 2 repeating decimals, the 5 does not repeat. The 6 does, and that makes it irrational. So take a look. These keep repeating. So it's going to go on forever. The 5 does not repeat. The 6 does, and that makes it irrational. So if you have 2 repeating decimals that are going to repeat, you can have an irrational answer. What if I have a repeating decimal as a fraction? Well, there's this cute little rule that I'm just going to go straight to the shortcut, which tells you if I had 0.3, that would be 3/10. 0.45, 45 hundredths, which reduces to 9/20. But what if that 3 repeats? When you have a repeating decimal, there is a 1-point penalty to the denominator for being repeating. It doesn't matter if it's 10 or if it's 100, if it's 10,000, it's still just -1. So 3 over 10 minus 1, 3/9, equals 1/3. 0.45, 45 over, it should be over 100, but it's not. It's over 99. I get 15 over 33, which equals 5 over 11. If all the decimals are repeated, this will work. If, however, only 1 was repeated, like if only the 5 was repeated, there is a completely different method, which is way more high-tech than what we're going to get into right now. But it is different. So use this information on a test. If one of the answers is 5/11, you know that's because both repeated. So don't choose that as one of your answers. That's it. Bye now.